So this would be part 3 of today's lesson. Perhaps you recall a very important equation from Algebra 1 that enabled you to write the equation of a line. It was called the point-slope formula and looked something like y minus y1 equals m times x minus x1. By simply renaming some of the values within the equation, we can come up with a powerful tool to write the equation of a tangent line. So here, now if you guys notice, if you struggle to come up with the point-slope formula, just remember that the slope equals the change in y over the change in x, which in this case is y minus y1 over x minus x1. And if you decide to multiply both sides by the denominator there, you get the point-slope formula. All right, so now we're going to take it a step further because this is calculus. So therefore, the theorem of the equation of a tangent line, so the slope of the tangent line exists. So if we already established that, then the equation of the tangent line to the graph of f at the point C, comma f of c, is given by y minus f of c equals f prime of c times x minus c. So here it's pretty much, right, the slope at that point, and then this is what the point should be at, right, f of c and c. So find example 6, the graph of the function f given below consists of 3 line segments. Find f prime at 4. So f prime at 4, so 2, if you guys notice, the graph is going by 2s, so we're looking for this value right there. So we're trying to figure out the slope right there. So in this case, we want to find first our 2 values, right? So f prime of 4 represents the slope of the tangent line there. So we got to remember, right? It's the slope of the tangent line, which in this case is going to have the same slope as that line. So here we can assume that f prime of 4 is equal to, this would be your, at the bottom over here, that would be your x and your x1, and then on top, that would be your y and your y1. Or in this case, right, since it is calculus, it's x commas, it's going to be your c values, right? They're going to be here, right? This is going to be your x minus c, okay? So we're looking at x minus c, which would be, in this case, 6 minus 0, right? That's your x and your x1. And then this is going to be your y and your y1, right? Your initial y is at the bottom. So that's going to be 13 minus 1. And then you guys get 12 over 6, which is pretty much positive 2. So we can say that f prime of 4 is equal to positive 2, which is right there. All right, example 7, the function f is defined on the closed interval from -2 to positive 16. The graph of the derivative of f, y equals f prime of x, is given below. So this is telling me, now this is the trick here. They use this to confuse you guys, so make sure that you always put the graph that you're looking at. So here, f prime, f prime, f prime. If they give you f, then put f, all right? But this is pretty much all the slopes between -2 and positive 16. So the point 14 comma -2 is on the graph of y equals f of x. An equation of the tangent line to the graph of f at 14 comma -2 is what? So here, this is our c comma f of c now, right? And then we're looking for the slope at 14. So let's look at 14, so which is equal to positive 3, all right? So we know that f prime at 14 equals positive 3. That's our slope of the tangent line, right? Which in this case happens to be the y value of this graph. So now we can substitute. We're going to say y, and then minus a -2 equals the slope of the tangent line of 14, f prime of 14, and then times x minus 14. So we simplify, we're going to get y plus 2 equals f prime at 14, which is 3 times x minus 14. And that's pretty much your answer. which would be B. And then lastly, we have if the line 2x plus 3y equals k is tangent to the graph of y equals f of x at the point where x equals 5, the value of the limit as x approaches 5 of f of x minus f of 5 over x minus 5 is what? So here we want to look for, right? We know that pretty much that the limit as x approaches 5 of f of x minus f of 5, f of 5 over x minus 5, that represents the slope, right? Represents the slope of the tangent, right? Because it's the definition pretty much. All right. And then when x equals 5 in this case, right? That's important as well. And then the next part of the information, that line is represented by 2x plus 3y equals k. So this is the slope, right? And then this is kind of like f of x. So we solve for y here. We're going to get y equals, right? Subtract 2x from both sides. You're going to get 3y equals negative 2x plus k. Divide both sides by 3. We end up with y equals negative 2/3 of x plus k over 3. Now we can say that therefore the slope of the tangent line, put it up here. So the slope of the tangent line at x equals 5, 2f of x actually, 2f of x at x equals 5 is negative 2/3, right? It's given right there.